on what's coming up or anything that I just stated? Okay. Any questions on work from last week before we look at 9-6? Is there anything I need to go over from what you've been working on? Good. Okay. Okay. All right, well then let's look at section 9-6. So section 9-6 is solving exponential equations and logarithmic equations. So what we're going to be doing, your two objectives is once you finish tonight, you should be able to solve both an exponential equation and a logarithmic equation. All right, so first of all, what does an exponential equation look like? Exponential equation is an equation with variables in the exponent. So if we look at this problem here, we have an equation and then our variables are in our exponents. So we call this an exponential equation. We call this an exponential equation as well because our variables, again, are in our exponents and we have an equation. We have two types of exponential equations. We have one where the base is the same on both sides. And then we have one where the base can be made to be the same on both sides. So an example where our bases are the same. Remember, your base is that big number beside your variable. So in this case, my base is 2 and my base is 2. Here, my bases are not the same, but I can make them the same. And so what that means by making them the same is, what can I do to 64 where it has a base of 2? So 2 to what power gives me 64? 2 to the 8th? Let's see. Nope. So 2 to the 8th power. Ooh, that's kind of big. So nope, not 64. Anyone? Two to the 6th, 2 to the 6th power. Yep, it's 64. So what I've done now is still made this equation equivalent because 2 to the 5x power did not change, and then 2 to the 6 is the same as 64. Okay, and that's what we mean by making the bases the same. When we have an equation like this, we can use a property that says if our bases are the same, then our exponents are equal. And then we can simply bring our exponents down and solve it. Okay, and we'll look at an example in just a moment. The second type of exponential equation we have is when our bases cannot be made the same. So for example, 3 to the x power is 20. There is no way that I can make these bases the same and still be able to solve it. And so what I will use here is what's called the property of logarithmic equalities. And this rule says that I can take the log or the natural log of both sides and it still remains the same, equivalent, and then use my power rule, okay? And again, I'm gonna explain, we're gonna work in some examples in just a moment. All right. Well, let's look at example 1. So example 1 says to solve the exponential equation. And so if we look at this equation, we'll see that it is our first case, our first type where our bases are the same. So that means because I have a base of 2 and a base of 2, I can simply drop my exponents down. So x is equal to 5x plus 6 and simply solve it for x. Okay. And so if I want to solve this for x, then I can move what? My 5x by subtracting 5x from both sides. And so then 1x minus 5x is negative 4x is equal to 6. And then divide both sides by negative 4. Okay. And so I get x is equal to negative 3/2. Okay. All right, let's look at example 2. So example 2 says 2 to the 5x power is equal to 64. So we go back and look at our types. This is like that second one where our bases are not the same, but we can make them the same. Okay. So if I have a base of 2, that's that 2 to the 5x power, then as we did earlier, what can we do to 64 to make it a base of 2? And that's where we get 2 to the 6th power. So now our bases are the same. And so now we can drop our exponent. And so we would get 5x is equal to 6. Divide both sides by 5. And our answer is x is equal to 6/5. Okay, questions there? Face-to-face and virtual, any questions? Good? Okay.
No, this is pretty.
Okay, good. All right. All right, so let's look at C. C is 4 to the 3x minus 5 power is equal to 16. Okay, so right now, my bases are not the same, but I want to see if I can make them the same. Is it possible? Yes? How? Very good. Okay, so I'm going to leave the 4 to the 3x minus 5 power the same, but I can rewrite 16 as 4 squared because 4 squared is the same as 16. Any questions there? Okay, so now my bases are the same, so I can drop my exponents down. So 3x minus 5 equals 2. And then from here, I just want to solve for x. So I can add 5 to both sides and get 3x is equal to 7. Divide both sides by 3. And my answer is x is equal to 7/3. Okay. All right, let's keep going. Example D says 3 to the x is equal to 20. Okay. So here, I cannot, if I look at my bases, my base with my x is 3, and my base here is 20. And so if I think about it, is there any way that I can make 20, still get 20, but have a base of 3? And that's not possible because 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. So there's no way. So now this is going to be that second type here, where my bases can't be made the same. So what I'm going to do is take the log of both sides. So the property says if I take log 3 to the x is equal to log 20, I am still keeping my equation balanced. Because remember, whatever I do to one side, I have to do to the other side. Okay? And so then this allows me to use my property, my power property, that says I can bring this x down. Remember, we learned this last week. So this becomes x times the log of 3 is equal to the log of 20. And then I'm solving for x. So what's keeping me from having x by itself? Anyone?
The log of 3.
Very good, the log of 3. And it's being multiplied. So what's the reciprocal of multiplying? Division. So
Division.
to get rid of log 3, I'm going to divide both sides by log 3. And so that gives me x is equal to log 20 over log 3. And so depending on which problem you're doing, you can leave it like this. If it asks for you to round it, we can put that in our calculator. So we would do alpha y equals. And remember, this is the common base. So I'm going to use this log here. Okay. And so we will do log 20 divided by log 3. So my answer would be 2 point, if I round to 4 decimal places. So 1, 2, 3, 4. Oops, sorry. Is that better? Okay. So 1, 2, 3, 4. That 3 tells me to stay the same. So this will be approximately 2.7268. Okay. So again, just depending upon what you're being asked to do, you might be able to leave it like this, but if it asks for you to round it, then this is the answer that you would give. Okay, questions on example D. Okay, let's look at E. So we have E to the negative T power is equal to 0.04. I cannot make my bases the same because I have a base of E and a base of 0.04. So I am going to take the log of both sides. Because I have a base of E instead of log, this is when I will use the natural log. So natural log of E to the negative T is equal to the natural log of 0.04. And just remember, whatever I do to one side, I have to do to the other to keep it balanced. Now I can use my power property, my power rule that says the exponent can come to the front. And so I end up with negative T times the natural log of E is equal to the natural log of 0.04. Okay. Now, I don't know if you all remember, but the natural log of E is equal to 1. Okay. So that means this can just go away, and I'm left with negative t is equal to the natural log of 0.04. And then I need to get rid of this negative. So t is by itself. So I just divide both sides by -1. And t is equal to negative natural log of 0.04. And again, if it's asking you, you can leave it like this, or if it's asking you to round it to the nearest 4 decimals, because that's usually what it's going to ask you on your assignment, we can put this in as negative. And then remember, our natural log button is the third up from the bottom, so right there. So the natural log of 0.04. And so we would get 3.2189 because that 7 tells me to round that up. And let's make that approximately. Okay. Questions on E? All right, let's look at F. So we have 5 to the x plus 2 power is equal to 4 to the 1 minus x power. How do we want to begin this? I have a base of 5 and a base of 4. Can I make them the same? No, I cannot. Yeah. Somebody said yes. Yes? How you want to make those the same? No. Do you understand why though? Okay. So if I have a base of 5 and a base of 4, there's no way that I can make these the same. Like 5, there's nothing to some power that's going to give me 5. And that same base for 4. So there's no way to make these the same. So when that happens, all I can do is take the log of both sides. So I get log of 5 to the x plus 2 power is equal to log of 4 to the 1 minus x power. Take the log of both sides, and now I use my power rule. So what do I end up with? This x plus 2 can come to the front. So I have now x plus 2 times log 5 is equal to, and I can do the same thing here, 1 minus x times log 4. Let me stop there and make sure everybody is with me. Questions? Okay. Now, this one is a little different than the ones that we've done up here because we have an x on both sides and we're trying to solve for x. So before we can solve for x, we need to get them together, okay? And so what I'm going to do is distribute the x plus 2 to my log 5. So x times log 5 is x log 5 plus 2 times log 5 is 2 log 5 is equal to, and I'm going to do the same thing over here. So what would I get?
1 log of 4.
Good. Minus,
X log of 4.
yep, x log 4. Okay. So now I can get my x's together. So this is just like a regular equation. I know it's kind of confusing because these logs are there, but I want to be able to get my x's on the same side. So I'm going to move this x log 4 over. And so since it's subtraction, I'm going to add it. So x log 4 plus x log 4. Now, I can't combine this together because this is a 2 and that's an x, and that's a 5 and that's a 4. So what I'm going to have is x log 5 plus x log 4 plus 2 log 5 is equal to log 4. Let me stop there and make sure everybody is with me. Mhm. Because that's a 5 and that's a 4, and so they're not the same. Right, so I didn't combine it. I just didn't have space over here. So see how I have this, this, and that? Yeah, so I didn't combine it, okay? Okay. All right, now I'm going to move this constant over. So I'm gonna subtract it. So minus 2 log 5 minus 2 log 5. So now on the left side, I have x log 5 plus x log 4 is equal to log 4 minus 2 log 5. And I promise you, I'm almost done. Any questions on this step? All right, so hopefully you recognize that we have what's our greatest common factor of x. And so what I'm going to do is factor it out. So x, open parentheses. If I take out x, that leaves me with log 5 plus log 4. And I didn't do anything over here, is equal to log 4 minus 2 log 5. Questions? Now, the very last thing I need to do is, remember, I'm solving for x. So what's keeping me from having x by itself?
The stuff in the parentheses.
Okay, I'll go with that. The stuff inside the parentheses, yes. And it's being multiplied. So to get rid of it, I am going to divide. So log 5 plus log 4. Divide this side, log 5 plus log 4. That allows this to cancel. X is now by itself. And so x is equal to log 4 minus 2 log 5 over log 5 plus log 4. And then we can put this in the calculator. Okay, so alpha y equals log 4 minus 2 log 5 divided by Let me back up. So log 4, I'm going to close my parentheses here, minus 2 log 5, then close my parentheses, divided by log 5 plus log 4. Okay, press enter, and I get negative 0.6117. Okay. Questions? Are you okay? Virtual students, any questions? Okay. All right. Okay, so that was solving exponential equations. Everything that we did involved an exponent, okay? Next, let's look at solving logarithmic equations. So a logarithmic equation is an equation in which we have variables in our logarithmic expression. So examples would be log base 2 of x equals 4, and log x plus log x plus 3 is equal to 1. Both of these are logarithmic equations because we have a logarithm, we have an equal sign, and our variable is in our expression, okay? Take note. You might want to highlight this or circle it. When we are solving logarithmic equations, we must check our answers to make sure that we are not taking the log of a negative number or 0. If you remember, I told you all when we first started looking at logarithms that the log of a negative number is undefined. So if your answer when we're solving the equation, we plug it back in and we end up trying to take the log of a negative number, then we have to throw that solution out. And we'll look at an example in just a moment. So we have 3 types of logarithmic equations. The first type is when we have one log in our equation. Log base 2 of x equals 4. And if we have this is really simple to solve. All we have to do is convert it from logarithmic to exponential. And we did this last week. So we would simply say 2 to the 4th power equals x. Remember this from last week? And then now it's exponential form, and then you know how to solve an exponential equation. Okay? The second type is when you have 2 logs on the same side. So log x plus log of x plus 3 equals 1. In order to solve this one, we're going to combine using our product or quotient rule, and then convert to an exponential equation and solve. So here we have log x plus log of x plus 3. So we have 2 logs. So we talked about this last week. When we see addition, what can we do to combine this together? Very good, multiply it. So this can become log x times x plus 3 equals 1. Now we have one log, and then we can convert this into an exponential equation. And then we solve it, okay? And then the third type is when we have an equation and a log on each side. And so here we can use our equality rule that says if we have logs and they're equal, then the expressions are equal. So this would simply mean x plus 4 equals 2x minus 3, and then I can solve it. So those are my three types. Okay. All right, let's look at examples. So example 2A says to solve the logarithmic equation. So here is our first type that we saw where we have a log on one side. So that means that we can simply convert it into an exponential equation. 2 to the 4th equals x. And then I'm going to solve it for x. So x is already by itself. So 2 to the 4th is 16. So that means my answer is 16. Okay, and remember, I always want to go back and plug it in to make sure I'm not trying to take the log of a negative number. So if I'm going to check this, this is going to be log base 2 of 16, and it should equal 4. So I could put that in my calculator. Alpha window. Remember, my log base is number 5. So log base 2 of 16 gives me 4. So this is correct. And so that means my answer is 16. Okay. Questions? Okay, let's look at B. Log base 5 of 8 minus 7x is equal to 3. Okay, how do you think we should work this one? Can we work it the same as we did on A? Why not? How many logs do we have? 1. So yes, we can. Looks a little different because there's an expression here, but it's still 1 log. So we can just set it up as an exponential. So 5 to the 3rd power equals 8 minus 7x. Let me stop there and make sure everybody is with me. Questions on what I just did? Okay. 5 to the 3rd power is 125. And all I'm going to do is bring down the 8 minus 7x. And then from here, I'm just going to solve it. So subtract 8 from both sides. 125 minus 8 is 117. Is equal to negative 7x. Divide both sides by negative 7. And I get x is equal to negative 117 over 7. Okay, let's go back in and check it. So log base 5 of 8 minus 7x should equal 3. I'm sorry, that should be 7. Let me redo that. Log base 5 of 8 minus 7 times negative 117 over 7 should equal 3. So alpha y equals, alpha window Moving too fast. Number 5. So my base is 5. And then inside my parentheses, I have 8 minus 7 times my x was negative 117 over 7. So I need to go get a fraction. Alpha y equals. And I get 3. So that means this is correct. So my answer is fine. Negative 117 over 7. Okay, question? Shadri, you okay? Okay. Virtual students, any questions? Okay. All right, let's look at C. So we have log x plus log of x plus 3 equals 1. So this one is not like A or B because we have 2 logs on the same side. So when we have 2 logs on the same side, then we can use our properties. If we see addition, that means we can rewrite it as multiplication. So this is going to become log x times x plus 3 is equal to 1. All I did was condense into 1 log, and because I saw addition, I multiplied these 2 expressions together, okay? And so now I can do what I did in A and B. I can convert it into an exponential equation. What base is understood to be here? If there's no base, what's understood to be there? 10, exactly. It's a common base. So 10 to the first power is equal to x times x plus 3. Again, if there is no base, it is understood to be a base of 10. All right, and then from here, we can simply distribute, and I'm gonna turn this around to what you all are used to seeing. So I'm just gonna rewrite it as x times x plus 3 is equal to 10 to the first power. And then I can distribute. So x times x is x squared plus 3x is equal to 10 to the first is 10. Okay, have I lost anyone? Okay, because I have a quadratic, that means I'm gonna have to solve this one by factoring. And so I need to bring my 10 over. So this is gonna become x squared plus 3x minus 10 equals 0. And then as we've done a number of times this semester, we're just gonna do our t-chart. So A times C, 1 times negative 10 is negative 10. And then my B is 3. So I need 2 numbers that multiply together to get negative 10, add together to get 3.
-2, -5? No. -2 and 5, I don't know.
Negative 2 and 5, yes. Negative 2 times 5 is negative 10. And then negative 2 plus 5 is 3, very good. So then I make my 2 parentheses. The first term of each is going to be x. And so I get x minus 2 and x plus 5. And then lastly, divide both sides by the GCF. In this case, it's going to be 1. So my factor form is x minus 2 times x plus 5 equals 0. And then remember, I'm going to now take each one and set it equal to 0. And so I get x is equal to 2 and x equals negative 5. Okay. So these are my two solutions right now, but remember, I have to check it. So let's start by checking x equals 2. So when I plug back in, I'm going to get log of 2 plus log of 2 plus 3 should equal 1. Okay, so I see here log, just a regular log, 2 plus log of 2 plus 3, and I get 1. So that means 2 is a solution. Okay, now let's go and check negative 5. So when x equals negative 5, so I'm going to have log of negative 5 plus log of negative 5 plus 3 equals 1. So I'm going to tell you right here, and you may not notice it, but I'm already going to get an undefined answer because I'm trying to take the log of a negative number. And remember, I told you we could not do that. And we actually did it in our calculator last week, and you saw that you got undefined. But even if you don't recognize that, when you plug it in, you're going to have log of negative 5 plus log negative 5 plus 3. And you're going to get the error. It's saying non-real answer. And that's because you can't take the log of a negative number. So that means that x equals negative 5 cannot be a solution. So our only solution here is x equals 2. Okay, any questions on that one? Okay. All right, 2 more. All right, example D. Natural log of x minus the natural log of x minus 4 equals the natural log of 3. So we have logs on both sides. So the first thing that we want to do is combine these logs here. So we see subtraction. So that means we can combine them using what? Division.
What did you say?
Division. This is our quotient rule. So we can rewrite this as the natural log of x over x minus 4 is equal to the natural log of 3. Then, remember I told you that you have a property that says if I have logs on both sides, if they're equal, then my expressions are equal. So here I have natural log and natural log. So they are the same. So that means these expressions can be equal. So I simply drop my logs and I have x over x minus 4 is equal to 3. And then from here, I can simply cross multiply. I put a 1 on the bottom because that's the same as saying 3. And then I get x is equal to 3 times x minus 4. Distribute my 3x minus 12. Subtract 3x from both sides. And I get negative 2x is equal to negative 12. And then divide both sides by negative 2. I get x is equal to 6. Right? And then if I want to check it, remember, just plug it back in. So the natural log of x is 6, so I can take the natural log of that. And then 6 minus 4 is 2. And the natural log of 2, I can take the natural log of. So my answer is x equals 6. Okay. Good. Okay. Virtual students, any questions before we look at the last one? All right. E. Log base 5 of x plus 4 plus log base 5 of x minus 4 equals 2. Okay, so how are we going to work this problem? So I have a log here and a log here with addition. So what can I do? Because I need to only have one log. So what can I do?
Multiply?
Good. Yes, I'm going to rewrite this using my product rule. So this becomes log base 5 of x plus 4 times x minus 4 is equal to 2. Then if I multiply this together, x plus 4 times x minus 4, if I distribute, I'm going to get x squared minus 4x plus 4x minus 16. So my middle terms cancel, and I have x squared minus 16. So, okay. So this becomes log base 5 of x squared minus 16 equals 2. Okay. So I now have one log. So what can I do? What?
Would it be 5 squared equals x squared minus 16?
Very good. Whenever I have the one log, then I can convert it into exponential form. So 5 to the second equals x squared minus 16. So 5 squared is 25. Is equal to x squared minus 16. So because I only have one x here, then I can just keep solving. So I'm going to add 16 to both sides. And I get 41 is equal to x squared I'll turn this around, how you all are used to seeing it. So x squared equals 41. And then I need to get rid of this square by taking the square root. So x is equal to plus or minus the square root of 41. So right now I have two answers. X equals positive square root 41 and x equals negative square root 41.
Can we go ahead and cancel that negative one now, since you said you can't do the negative because it make it undefined or something like that?
Yes, you can, but just make sure that it's gonna work. So what I mean by that is, so what is negative square root 41? So if I put it in right here, negative square root, oops, negative square root, where's my radical? 41 plus 4 gives me a negative number. So yes, Dakota, you are correct. If I put it in right here, that's going to give me a negative 2.4, and I can't take the log of a negative number. So yes, I'm going to throw that one out. And my only answer is square root 41. Okay. Question.
So going back to the,
Mm-hmm.
how would we, do we put that in the calculator to get the six?
To get the 6.
I mean, x equals 6, is that
What do you mean put it in the calculator? Are you talking about check it?
to check?
Mm-hmm. So what Shadria asked is, can we put this in the calculator to check it? Yes. So remember your LN is right here. First column, 1, 2, 3 up. Okay. So you would type in, make sure y'all, can y'all see that? It's a glare. So LN, my X is 6 minus natural log 6 minus 4. And that gives me 1.0986. So now I need to see what the natural log of 3 is. So natural log of 3 gives me the exact same thing. So that means this is correct. Okay?
So that's why I was confused.
Mhm.
No, that didn't equal 3. Okay.
Okay. The natural log, remember that 3 has a natural log, so you still
Okay.
have to take it.
So if it
Okay?
was by itself, then it would not equal 0. Okay.
Exactly.
I got you.
Mm-hmm. Okay. Good job. I'm glad you checked it just to make sure. All right. Any other questions? Okay. Before I let you all go, guys, I have a number of you all with missing assignments from last week. Okay, they are considered late at this point, but that cutoff date is the 30th. So you still have some time to do it. So a number of you all need to go in and look at your grades because you haven't done assignments, and I put them in as zeros right now, and that has dropped your grade. So you need to go, and if you are missing an assignment, you didn't do it on time and it's still open, you need to get it done. Do you all have any questions before I let you go?